So today we're going to be talking about scale factors and scale drawings. It's not the first day that we've talked about scale drawings, but I do know it's been a while. Okay, scale drawings is way back in Module 1 we learned there's two types of scale drawings, right? So I'm talking about a scale drawing. That means there's going to be a drawing that's going to change sizes. It's still going to be proportional, but it's going to either look bigger or smaller, right? So the two types of scale drawings that we have, hopefully you remember that, we're talking about reductions, we're talking about enlargements. So the first question here says compare the corresponding lengths of figure A to the original octagon in the middle. So it's really important to know that the original octagon is the one here in the center. And it's important to realize that this is the original because as we learned earlier in this module with the percent, especially when we're talking about percent changes, the original is where you're going to start. Okay, so if I'm going to compare figure A and the original, figure A is quite obviously smaller than the original, which means this one's going to have to be a reduction. Now you have a little bit of space here. It says explain why it is called that. In your own words, how do you know this is going to be a reduction? Doesn't have to be real long here, but get yourself a little bit of a response. So similarly, then the bottom half of the page says compare the corresponding lengths to figure B. Okay, again, the original one's going to be the one in the middle. So we're going from the original to figure B, right? How does figure B compare to the original? This one would have to be the enlargement. Again, these are not new words for us. You've had these months ago. It's just a chance to refresh your memory. Explain why it is called that. How do you remember that an enlargement means the figure is getting bigger? How do you know that this one fits that definition? So those were the two easy questions. Now we're getting into the scale factor, which is what you guys were nervous about doing last time. You guys did not enjoy doing this. But hopefully after you spend as much time as you did with percents, you guys will see that this really isn't that bad. The scale factor is the quotient of any length in the scale drawing to its corresponding length in the actual. Okay, so once again, we're comparing the scale drawing to the actual drawing, and it says use what you recall from Module 1. Okay, so the first one they want me to compare is original figure and figure A. So looking at the measurements that they tell me in the original and figure A, it looks like the top of my shape here is 1.5, doesn't tell me inches or centimeters or feet or whatever, is 1.5, and in the original shape the corresponding length is 3. Okay, we're using the top of both. So the top is 1.5 and the top is 3. Now I know this is a reduction, right? So I want to know how much smaller it is. Okay, so I have two choices here. If my numbers are 1.5 and 3, is it more correct to say 1.5 over 3, or is the scale factor 3 over 1.5? Right? If I'm talking about a reduction, that means it's getting smaller, right? Which of these fractions is going to give me a number that's smaller than 1? Well, the first one, 1.5 over 3, your calculator will tell you, you can figure this out here. 1.5 is half of 3. Right, so the scale factor would be 1/2. Now we've been using decimals a lot here recently, so really 1/2, that's the same as 0.5, which we also know, we spent a lot of time on this. 0.5 is the same thing as 50%, right? So the scale factor is 50% reduction. Right? It has been reduced to a factor of 50%. Is 50% the size of the original shape? I am going to have to change the font size on this, make it a little bit smaller, because I do want you to do the original figure and figure B as well, right? So while I'm changing the font size, getting everything lined up, you've got this time, what would the scale factor be from the original to figure B? All right, so take the time to copy this down if you haven't already. The scale factor is 4.5 over 3, which we got from looking at the top of figure B and the top of the original shape, 4.5 compared to 3. Now 4.5 has to go on top because I know this is going to be an enlargement, right? So it's going to be 1.5 or 150%. Right, so we already know 150%, that's going to be larger than whatever we started with, right? 150% is going to make things much larger. So that's what they're looking for figure B. So this is going to look like the same type of question as the last one. This is use the diagram to complete the chart below to determine the horizontal and vertical scale factors. All right, so we're not going to review horizontal and vertical. You know both of those. It says write the answers as a percent. Okay, so there's the key. If it's saying write them as a percent, we already know all kinds of stuff about percents. This is what we had trouble with the first time we learned about scale factor, but now you're going to realize it's going to be one of the simplest things we've done. Okay, because when it says horizontal measurement in the scale drawing, we want to know the scale factor as a percent. Okay, so that means that we're just going to be using the percent formula that we've known for weeks. Now I am going to use the percent sign just because this box isn't very big. Part is equal to the percent times the whole thing. Now again, we learned when we were talking about these percents that if I'm looking for the whole thing, the more important word than the whole thing, okay, is oftentimes just going to be the original. Where are we starting? The original amount is going to be the whole thing. So what I'm trying to figure out then is what percent of the original is the new scale drawing. And we know from the diagrams on the first page, you can flip back to see that for the horizontal measurement, the original octagon had a horizontal measurement of 3. Right. We also know the new shape, the reduction, had a size of 1.5. Again, doesn't tell me 1.5 what, okay, inches, centimeters, feet, whatever. What I'm trying to figure out is what's the percent that I would multiply by 3. Okay. And what that tells me is that the percent is going to be 0.5, which we know would show me 50%. All right, now that's a lot to fit in the first box, but it really sets us up to have some shortcuts for the rest of the boxes here, okay? I don't need to go the whole way back to part equals percent times whole. I know what I'm looking for is that the new scale drawing is equal to a percent of the original. Okay. But this time we're looking for the vertical measurements, looking for the measurements that are going up and down. In this case, the original shape is, oh, come on, you can look back to the original shape is 4 tall, and the new one is 2. All right, so what I'm looking for is what percent of 4 is 2. All right, now good news is here, the percent's going to be the same thing, horizontal and vertical. 0.5 is equal to the percent. All right, so here's my concluding statement then. If this one is 0.5, the vertical is also 0.5. Since they're both the same, right? Since it's shrunk the same amount horizontally and vertically, that means the scale factor is 0.5, right? Which could tell me that figure A is 50% of the original. And since it is 50%, we know that's going to be a reduction. Okay. So figure B, same thing. This one's going to be more on your own. For the concluding statement, what you want to be able to tell me is what's the scale factor. And then figure B is something compared to the original, and then would that be a reduction or an enlargement? Right, that's the third thing you're looking for, reduction or enlargement. So go ahead, take as much time as you need. You got plenty of time here today. Figure B, complete that chart.